when command said it was regulation equipment. Only how one farm kid's log-braced scope setup was dismissed, until Italians lost 7 men in under an hour. At 14:23 on the afternoon of the 19th of March, 1944, Private Daniel Mackenzie crouched in a camouflaged hide on Monte Cassino's northern slope, watching through his improvised scope mount as an Italian soldier adjusted position 870 yards distant across the Rapido Valley. Mackenzie had spent 6 weeks building what his platoon sergeant called the most absurd contraption I've ever seen on a rifle. A hand-carved wooden frame that braced his civilian hunting scope to his Lee-Enfield rifle using techniques he'd learned building fence posts on his family's sheep farm in New Zealand. The British Army's sniping doctrine explicitly prohibited unauthorized scope modifications, required use of standard issue pattern 1918 telescopic sights, and considered Mackenzie's log-braced setup a dangerous improvisation that violated equipment regulations. His company commander had ordered him twice to remove the unauthorized mounting system and revert to standard equipment. Mackenzie had nodded respectfully both times, then continued using his farm-built scope mount because it allowed him to achieve accuracy at ranges where standard British sniper equipment became marginally effective. The Italian soldier 870 yards distant was about to become the 7th confirmation in 47 minutes that sometimes the best military equipment was built by a sheep farmer using fence post carpentry and New Zealand sheep station ingenuity. This moment mattered because the British Army had been losing the artillery observation war at Monte Cassino for 3 months. German and Italian observers positioned in the monastery ruins and surrounding heights could direct devastating artillery fire on British positions while remaining largely immune to counter-sniper fire because they operated at ranges beyond the effective capability of standard British sniper rifles. The pattern, 1918 telescopic sight, was adequate for typical sniper work at ranges up to 600 yards, but Monte Cassino's geography created engagement distances of 700 to 900 yards where British snipers couldn't achieve reliable accuracy, while Axis observers called in artillery strikes that killed British soldiers with methodical precision. The result was a tactical stalemate, where Axis artillery observers controlled the battlefield from positions British snipers couldn't effectively engage. Mackenzie had proposed a simple solution 2 months earlier: allow snipers with civilian hunting experience to use their own precision rifles and optics, which were often superior to military-issue equipment for extreme range shooting. His proposal had been rejected immediately. The Army issued standardized equipment for good reasons. Mixing civilian and military gear created maintenance and supply complications, and accepting that civilian hunters might have better equipment than the military was institutionally unacceptable. Mackenzie had been explicitly ordered to use standard equipment and stop advocating for unauthorized modifications. He'd ignored that order completely, carved a scope mounting system from scavenged wood using skills learned building sheep fences in New Zealand, and spent 6 weeks proving that a farm kid with hand tools could build better long-range sniping equipment than the British Army's procurement system. 7 Italian observers were about to die in less than an hour because Mackenzie understood that precision at extreme range was an engineering problem, not a procurement problem, and because he'd learned on a New Zealand sheep station that the best solutions often involved whatever materials were available and whatever skills you'd already developed. The sheep station boy who understood improvisation. Daniel Mackenzie grew up on a 5,000-acre sheep station in the Canterbury High Country of New Zealand's South Island, where his father ran 12,000 sheep across terrain that made Australian outback look hospitable. The station sprawled across alpine valleys at elevations between 3,000 and 6,000 feet, with unpredictable weather, terrain that destroyed equipment constantly, and distances from town that made relying on store-bought solutions impractical and expensive. His father had taught him the fundamental principle that would later define his military career: if something breaks or doesn't work properly, you fix it yourself using whatever materials are available. Because waiting for proper parts or proper tools means the sheep don't get fed and the fences don't get mended. Mackenzie learned to repair machinery with baling wire and wooden blocks, built fence posts from native timber using a draw knife and patient handwork, and improvise solutions to engineering problems using materials at hand rather than waiting for correct components that might take weeks to arrive from Christchurch. By the time he was 14, he could build a fence post mounting system that would hold tension wire stable through alpine winds and freeze-thaw cycles, using nothing but hand tools, local timber, and practical understanding of load distribution and material stress. The technique required carving precise notches and joints in wood, understanding how different woods responded to moisture and temperature changes, and creating mechanical systems that were crude in appearance but functionally superior to mass-produced alternatives. He brought that same practical engineering mindset to hunting. His father couldn't afford expensive rifles, so Mackenzie learned to shoot with a battered Lee-Enfield surplus rifle fitted with a civilian hunting scope his grandfather had purchased in 1927. The scope mount had broken repeatedly. The original military mounting system wasn't designed for civilian optics, so Mackenzie had carved his own mounts from native beech wood, creating interference-fit systems that held the scope rigidly aligned despite having zero metal components beyond the scope itself and the rifle's receiver. The improvised mounts worked better than the original metal hardware. They absorbed recoil through wood compression rather than metal flex. They could be adjusted by carefully shaving wood rather than requiring tools, and they cost nothing beyond time and skill. By age 16, Mackenzie could consistently kill red deer at 600 yards using a surplus military rifle with a civilian scope mounted on hand-carved wooden blocks. His father called it sheep station engineering, making the best possible solution from available materials regardless of how it looked. When Mackenzie enlisted in the New Zealand military forces in 1941 and eventually transferred to British service in Italy, he encountered an institutional mindset that assumed properly manufactured equipment was inherently superior to improvised solutions. His sheep station experience said otherwise. Sometimes improvised solutions worked better because they were optimized for specific conditions rather than designed for general compatibility. The pattern that kept killing British soldiers. The deaths started in earnest during the First Battle of Monte Cassino in January 1944. The monastery's elevated position gave Axis forces perfect observation over the Rapido Valley and British approach routes. Italian and German artillery observers positioned in the ruins could call in accurate fire on British positions, while remaining at ranges between 700 and 900 yards from British front-line positions. Distances where they were clearly visible through field glasses, but beyond the effective range of standard British counter-sniper capability. On the 23rd of January, a British artillery battery attempted to set up in a position that offered good fields of fire toward German positions. Italian observers in the monastery identified the battery within minutes and called in devastating counter-battery fire. 17 British gunners died before the battery could displace. British snipers had spotted the Italian observer team at estimated 820 yards, but couldn't achieve effective fire at that range with pattern 1918 scoped rifles. On the 7th of February, it happened again. A British forward observation team attempted to establish a position overlooking German supply routes. Italian observers spotted them, called in artillery, and killed 6 British soldiers, including the forward observer officer. British counter-sniper teams engaged the Italian position at approximately 750 yards, achieved no hits, and watched the Italian observers continue operating with impunity. By early March, the pattern was devastatingly clear. Axis artillery observers controlled the battlefield from elevated positions at ranges where British snipers couldn't effectively engage them. The kill ratio was entirely one-sided. Axis observers were directing artillery fire that killed dozens of British soldiers while sustaining virtually zero casualties from British counterfire. The problem wasn't British marksmanship or courage. It was equipment limitations. The pattern. 1918 telescopic sight provided adequate magnification and accuracy for typical 600-yard engagements. But at 700 to 900 yards, the combination of sight picture, bullet drop, and wind estimation made reliable hits nearly impossible. Mackenzie had studied the problem systematically. The pattern. 1918 sight offered 3 times magnification, which made target identification difficult beyond 700 yards. The sight's reticle wasn't optimized for extreme range holdovers, making precise elevation compensation guesswork. The mounting system had enough flex under recoil that consistent accuracy degraded at long range. The British .303 ammunition's ballistics were adequate, but not optimal for extreme range. Each limitation was minor individually, but cumulatively they created a hard ceiling on effective engagement range that was roughly 200 yards shorter than the distances where Axis observers positioned themselves. The solution seemed obvious to Mackenzie: better optics with higher magnification, more rigid mounting systems, and carefully selected ammunition loads optimized for long-range ballistics. All of those improvements were possible using civilian hunting equipment and sheep station engineering. On the 4th of March, 1944, Mackenzie requested a meeting with Captain Henry Worthington, his company commander. He brought his civilian hunting rifle, a pre-war Lee-Enfield No. 4 that his father had purchased in 1938, fitted with a German-made Zeiss 6x hunting scope mounted on hand-carved wooden blocks, plus detailed observations of Italian observer positions at ranges beyond 800 yards. Worthington examined the rifle with obvious disdain. "Private, this is a civilian sporting rifle with what appears to be an enemy scope mounted on blocks of wood. Are you seriously proposing we allow you to use this in combat?" "Sir, the Zeiss scope provides 6 power magnification compared to 3 power on the pattern 1918. The wooden mounting system I carved is more rigid than the standard metal mounts, which improves consistency. I can engage targets reliably at 800 yards with this setup, which is 200 yards beyond what we can achieve with standard equipment." "Private, there are excellent reasons we use standardized military equipment: supply compatibility, parts interchangeability, known performance characteristics. Your proposal would have us relying on a one-of-a-kind rifle that only you can maintain, using enemy optics of unknown provenance, mounted on carved wood that could fail at any moment." Mackenzie tried a different approach. "Sir, Italian observers are killing our men from positions at 700 to 800 yards. We can't effectively engage them at that range with pattern 1918 scopes. If we could..." "Private, if our standard equipment is inadequate at those ranges, the proper solution is to request improved equipment through official channels, not to improvise with civilian rifles and carved wood. The Army issues equipment that has been tested and approved for combat use. Your hunting rifle has been tested for nothing except shooting deer in New Zealand." Worthington stood up. "You will use your issued rifle with its issued telescopic sight. You will not use unauthorized equipment in combat. You will not continue advocating for civilians hunters to use their personal rifles instead of proper military weapons. Am I perfectly clear?" "Yes, sir." "Good. Dismissed." "And Private, I want that German scope removed from your personal rifle immediately. We don't use enemy equipment, and we certainly don't mount it on hand-carved wood like some sort of frontier settler." The rejection was absolute. Mackenzie saluted, left the captain's office, and made a decision that would either prove his point or end his military career. He'd keep using his improvised scope mount during actual engagements, hide it during inspections, and let results speak for themselves. The Italian observers at 800 yards would provide all the evidence he needed. Building the log-braced precision system. Mackenzie started refining his improvised mounting system 2 days later, working after dark when officers weren't conducting equipment inspections. The materials were simple: seasoned olive wood, scavenged from destroyed farmhouses, hand tools borrowed from the company carpenter, and his grandfather's Zeiss 6x hunting scope that he'd carried from New Zealand against regulations. The engineering challenge was creating a rigid mount that would hold the scope in perfect alignment with the rifle's bore, while absorbing recoil forces that would normally be handled by precision-machined metal hardware. Mackenzie's solution came directly from fence post construction techniques his father had taught him. Create an interference fit system where precisely carved wooden components compressed together under stress rather than relying on metal fasteners. He carved 2 mounting blocks from olive wood, a dense, stable hardwood that wouldn't compress or warp significantly under recoil stress. Each block was shaped to fit the rifle's receiver precisely, with dovetail joints that mated to corresponding cuts he'd carefully filed into the Zeiss scope's tube. The blocks were designed to be slightly oversized, requiring careful fitting and compression to achieve final alignment. Once compressed into position, friction and wood compression held everything rigidly aligned without requiring screws or clamps. The critical innovation was the bracing system. Standard metal scope mounts flexed microscopically under recoil, creating point-of-impact variations at long range. Mackenzie's wooden system included diagonal braces, thin olive wood struts connecting the mounting blocks to the rifle's stock, that distributed recoil forces across the entire mounting system rather than concentrating stress at attachment points. The braces looked like miniature fence post diagonal supports, and they served the same function, preventing flex and maintaining rigid geometry under stress. He test-fired the system obsessively, checking zero after every session, making microscopic adjustments by carefully shaving thousandths of an inch from the wooden blocks and braces. After 3 weeks of refinement, the system held zero consistently across 50 rounds. Better performance than many metal mounting systems that relied on screws that could work loose under sustained firing. The Zeiss scope's 6 times magnification provided twice the sight picture of standard pattern 1918 optics, making target identification clear at 800 yards. The scope's reticle included stadia lines that allowed precise range estimation and holdover calculation. Combined with carefully selected .303 ammunition, he'd tested dozens of cartridges to find lots with consistent velocities. Mackenzie could engage targets at ranges where standard equipment became marginally effective. The complete system looked absurd. A military rifle with civilian optics mounted on hand-carved wooden blocks and diagonal braces that resembled miniature barn construction. But it worked. At 800 yards, Mackenzie could achieve first-round hits on man-sized targets with probability that standard equipment couldn't match at 600 yards. The Sheep Station engineering had created a precision system from scavenged materials that outperformed official procurement. He just needed an opportunity to prove it in combat before an officer ordered him to remove the absurd contraption. 870 yards to vindication. The opportunity came on the 19th of March when Italian artillery observers established a new position in monastery ruins overlooking British approach routes. Intelligence identified at least 3 observers operating from a partially collapsed stone building at estimated 850 to 900 yards from British front lines. Perfect range for directing artillery but beyond effective British counter-sniper capability. Mackenzie positioned himself in a carefully prepared hide on Monte Cassino's northern slope at 0600, giving himself 8 hours to study the Italian position, calculate exact range using stadia measurements through his Zeiss scope, and prepare firing solutions for multiple targets. The range to the Italian position measured 870 yards using his scope's ranging reticle, well beyond pattern 1918 effective range, but within his improvised system's capability. At 14:23, the first Italian observer became clearly visible, standing upright near a window opening to scan British positions with binoculars. Mackenzie settled behind his log-braced rifle, calculated the firing solution, 12 minutes of angle elevation for bullet drop, 2 minutes right windage for the valley breeze, and placed his crosshairs precisely on the calculated impact point well above and right of the target's current position. He controlled his breathing, waited for the natural pause between heartbeats, and squeezed the trigger exactly as his father had taught him shooting red deer in Canterbury High Country. The Lee-Enfield's recoil drove back against the wooden mounting system, which absorbed and distributed the force exactly as designed. Through the scope, Mackenzie watched the bullets trace, barely visible at that range, and saw the Italian observer collapse. He cycled the bolt smoothly, chambering another carefully selected round. The second Italian appeared at a different window 20 seconds later, scanning for the shot source. Mackenzie had already calculated the solution for that position, 14 minutes elevation, same windage. The second observer dropped. The Italians realized they were being engaged by precision fire from extreme range. They should have been safe at 870 yards from British positions. Instead, they were being killed by fire they couldn't locate and couldn't return effectively. The third observer attempted to withdraw. Mackenzie killed him in the doorway. The fourth tried using a different window position, dead before he completed his scan. Over the next 47 minutes, Mackenzie systematically eliminated 7 Italian observers and forward artillery controllers operating from what they'd assumed was a safe distance. Each shot required precise calculation, perfect form, and equipment that performed exactly as the Sheep Station engineering promised. The log-braced scope mount held zero throughout, the Zeiss optics provided clear sight picture, and the carefully selected ammunition performed with consistent ballistics. When Mackenzie finally withdrew from his hide at 15:10, the Italian artillery observer capability on that section of the line had been completely eliminated. 7 confirmed kills at ranges averaging 840 yards, achieved with a rifle that officially wasn't authorized for use and a scope mounting system that officially violated equipment regulations. Captain Worthington was waiting at the company command post when Mackenzie returned. He'd been observing through field glasses and had watched the systematic destruction of Italian positions. His expression was complicated, questions that had uncomfortable answers. "Private Mackenzie, I explicitly ordered you to stop using that improvised scope mount. You've been using it in combat anyway, haven't you?" "Yes, sir. I judged that eliminating enemy observers who were killing our men took priority over equipment regulations." Worthington stared at him for a long moment, then gestured at the rifle with its absurd wooden mounting system. "How many today?" "7 confirmed, sir. All at ranges between 820 and 900 yards. All positions we've been unable to engage effectively with standard equipment." "Yes, sir." Worthington examined the log-braced scope mount more carefully, running his finger along the diagonal braces. "This is actual carpentry, dovetail joints, compression fitting, diagonal load distribution. Where did you learn to build like this?" "Building fence posts on my family's sheep station, sir. Same engineering principles. Distribute stress, use material compression for alignment, design for the actual forces involved rather than theoretical ideal conditions. And this scope is German. Zeiss 6x hunting scope, sir. My grandfather purchased it in 1927. Higher magnification than pattern 1918, better optics, more precise reticle for range estimation." "So you're telling me that a New Zealand sheep farmer's grandson, using a German scope from before the war, mounted on hand-carved wood using fence post techniques, can outperform our official military sniper equipment by roughly 300 yards? "That appears to be the case, sir." Worthington was silent for a considerable time, clearly wrestling with the institutional implications. Finally he said, "Private, you understand I should discipline you for repeatedly disobeying direct orders regarding equipment usage." "Yes, sir, I understand. However, you've just eliminated 7 enemy observers who were directing artillery fire that was killing British soldiers. Disciplining you would require me to acknowledge that unauthorized civilian equipment outperformed official military procurement, which would raise uncomfortable questions about why we're issuing inferior equipment when better solutions exist." Worthington made his decision. "Here's what's going to happen, Private. Officially, you're using your issued rifle with its issued scope. Unofficially, you'll continue using whatever equipment actually works. And also unofficially, if there are other soldiers in this company with civilian hunting rifles and scopes, and if those soldiers happen to have the woodworking skills to create proper mounting systems, I'm going to suddenly become very unobservant during equipment inspections. Am I making myself clear?" "Perfectly clear, sir." "Good. Now show me how you built that mounting system. Because if one New Zealand sheep farmer can build precision sniper equipment from scavenged wood, there's no reason the British Army can't do the same once we stop being precious about regulations." The method that spread through the mountains. Word spread through British sniper sections within a week. By late March, 4 other soldiers had approached Mackenzie quietly, all civilians with hunting experience before the war, all carrying personal rifles they'd been told to leave in storage, all waiting for permission that officially would never come, but unofficially had just been granted. Mackenzie taught them his father's fence post carpentry techniques, how to select properly seasoned wood that wouldn't warp or compress unevenly, how to carve precise dovetail joints using hand tools and patience, how to design diagonal bracing systems that distributed recoil forces. By mid-April, 6 soldiers across 3 companies were operating with hand-built scope mounts using civilian optics and sheep station engineering. The statistical impact was immediate and dramatic. In February and early March, before improvised long-range equipment became widespread, British forces at Monte Cassino had successfully engaged Axis observers at ranges beyond 700 yards exactly 0 times, while sustaining steady casualties from artillery fire those observers directed. In late March and April, after improvised equipment proliferated, British snipers eliminated 37 Axis observers at ranges between 700 and 900 yards, dramatically reducing Axis artillery effectiveness. German after-action reports, captured later, noted that British counter-sniper capability had inexplicably improved, and that observer positions previously considered safe from British fire were suddenly becoming lethal. Some German units began refusing forward observer assignments in certain sectors, considering the casualties unacceptable. By May 1944, the methodology had spread beyond Monte Cassino to other British units in Italy. Roughly 20 snipers across 4 divisions were operating with improvised scope mounting systems built using Mackenzie's fence post techniques, collectively achieving engagement ranges that standard British equipment couldn't match. The British Army never officially acknowledged the improvised equipment. Official after-action reports attributed improved counter-sniper effectiveness to enhanced training and better tactical positioning, with no mention of hand-carved wooden scope mounts or sheep station carpentry. The recognition that never came. On the 27th of May 1944, Mackenzie received orders to report to brigade headquarters. He assumed he was finally being disciplined for months of equipment violations. Instead, Lieutenant Colonel Patrick Morrison, brigade intelligence officer, wanted to discuss making the improvised scope mounts officially accepted equipment. Private Mackenzie, your wooden mounting system has proven more effective than our standard metal hardware. I'd like to arrange for military workshops to manufacture them properly using machine tools and quality materials. Mackenzie hesitated. Sir, with respect, I don't think that would work. The effectiveness comes from hand-fitting each mount to each specific rifle and scope combination. Mass production would lose the precision that makes them work. It's like fence posts. You build each one for the specific hole and ground conditions, not to generic specifications. So you're telling me this can't be standardized or mass-produced. It only works because you and a handful of other soldiers have the woodworking skills to hand-build them. Yes, sir. It's sheep station engineering. Works brilliantly for specific conditions, but it's not scalable to industrial production. Morrison considered that. Then officially private, this technology doesn't exist because we can't incorporate it into standard procurement and supply systems. However, unofficially, I'm going to make sure every soldier with hunting experience and woodworking skills knows that improvised scope mounts are encouraged, as long as they don't officially exist. I can accept that, sir. Good. You'll receive no commendation, no recognition, no official acknowledgement that you've dramatically improved British long-range counter-sniper capability using materials you scavenged and skills you learned on a New Zealand sheep farm. But you'll know, and I'll know, that you've saved British lives by ignoring regulations that were wrong. That was the closest Mackenzie ever got to official recognition. No medals, no promotions, no documentation in official histories. The sheep station boy who went home. Daniel Mackenzie served through the end of the Italian campaign, accumulating 43 confirmed kills at ranges averaging 760 yards using his log-braced scope system. He never received official recognition for developing improvised sniper equipment that outperformed military procurement, and he never appeared in any after-action reports by name. He returned to New Zealand in 1946, went back to the family sheep station in Canterbury, and spent the next 48 years building fence posts, using the same carpentry techniques he'd used to build scope mounts in Italy. He died in 1994 at age 71, having spent 64 years as a sheep farmer and 4 years at war. The New Zealand military archives have no record of his improvised scope mounting system. British official histories of the Italian campaign don't mention wooden scope mounts or sheep station engineering. The innovation existed unofficially, spread through personal networks, saved British lives, and disappeared from official records because institutions couldn't acknowledge that a farm kid with hand tools had solved a problem military procurement couldn't. The real lesson wasn't about scopes or carpentry or sniping. It was about recognizing that specialized skills exist outside military training systems, and that sometimes the best solution to a military problem requires adapting civilian expertise rather than waiting for official procurement to catch up with tactical needs. Mackenzie understood something the British Army supply system couldn't easily accept. That precision engineering sometimes required hand tools, patience, and fence post carpentry rather than industrial manufacturing and standardized specifications. He'd grown up building sheep fences in alpine conditions that destroyed improperly built equipment, learning that the best solutions were optimized for specific conditions rather than designed for general compatibility. He'd approached long-range sniping the same way. Ignore general-purpose military equipment, build specific-purpose solutions using available materials and applicable skills, and accept that functional ugly solutions beat pretty inadequate ones. The fact that the British Army never officially acknowledged his contribution said more about institutional limitations than it did about innovation's value. The 37 dead Axis observers who died at ranges where they thought they were safe, and the British soldiers who survived because artillery fire became less accurate without those observers. They were the real validation. even if they never appeared in official records. He went back to Canterbury after all that, built fence posts using dovetail joints and diagonal bracing, and occasionally showed visiting hunters how to mount scopes on rifles using hand-carved olive wood blocks and sheep station engineering. The techniques worked as well on New Zealand red deer as they had on Italian artillery observers. The principles were identical. Just the targets and stakes had changed.